We are making a donut purely from geometry nodes. In previous episodes, we've made the actual donut and the glazing on top of it. It was quite the job. If you've missed those videos, you can go and watch them in the playlist that I've linked in the description. In this video, we'll make all the various sprinkles that go on top of our glazing. So strap in and let's begin. The way we're going to create our sprinkles is we're going to create points on the surface of our glazing, and we're going to instance the various sprinkle geometry on those points, like that. So our first job is to create the points. We're going to do that with a special node called distribute points on faces. If we feed this node some mesh, we're going to end up with a bunch of points randomly distributed on its surface. To control this, we have a density slider, basically how many points are going to be created, and this is the seed of the randomness. But as you can see, the points are created everywhere, whereas we want them to be only on the top. We have a selection here, so let's make a selection only for the top part of our glazing. As usual, we're gonna use our vertical gradient. However, we're gonna need to modify it so it selects faces, because right now it applies to the points and it's not going to work like that. So I can make a copy of the node tree with this button. That way we don't change the ones we've already used. I'm gonna call this vertical gradient face. Inside the node group, change the sample index to face. Also, we need to evaluate the index field on the face domain. I'm gonna ungroup the normalize and set this one to faces as well. Okay, that should do it. If we don't do that, the distribute points on faces will get confused with the indices and it will give us the wrong distribution. So do it. Now I'm going to use a compare node with a greater than, so that we can change how high our sprinkles will be. Let's quickly make a control out of this with our usual way with a mix node. This is going to be from around here, around 0.5, to about here, the maximum height, 0.9. Okay, output the factor, and I'm gonna call this sprinkles height. Okay, but now it selects on the inside of the glazing as well. We want only in the top. So what we can do back here, when we solidified the glazing, we have a top selection. I can drag it from here and make a reroute node. Then I can just move it closer to the other nodes. I can rename it with F2, outside mask. Okay, so to remove the bottom of this, we can use a Boolean math node. Then, using the AND, we can just combine these two. That way, we've removed the inside. And we can use this, but what I like to do is blur this a little bit. That way, we will have more sprinkles on the top and a bit less here on the side. Okay, now this is our sprinkles mask. Let's get back to the points. We can combine the distribute points on faces with an instance on points node. That way, in place of those points, we can instance some geometry. Okay, we are gonna make three types of sprinkles. We're gonna make these bows, these stars, and these little sticks. We're gonna make them in order of complexity, starting with these balls. I can create a simple ball with an icosphere. Plug it in the instance here. They're a bit big, so let's lower the radius and increase their subdivisions so it looks more like a ball. We can shade them smooth with a set shade smooth node. Okay, straight away you can see we have this overlap going on. We have a random distribution of points, and there's bound to be some that are really close to each other. To fix this, we have the option to use a Poisson disk distribution here in the distribute points node. What this would do is when it creates a point on our surface, it's going to consider some radius around this point. That is, it's not going to create another point inside this area. It still is going to create randomly distributed points, but there's going to be some minimum distance between them. And that distance is this distance min. Something like this. Usually it's going to be twice the radius of the sphere. Okay, we can connect these instances with the rest of the donut here in the join geometry node. I've already did it. Now, to make them appear only on the top, let's join our sprinkles mask into this density factor. Then, with the density max, we can determine how many of them we want. Okay, but now you can see they are half submerged inside of our glazing. So what we can do after this, we can use translate instances. Now we can move them on Z until they are slightly above the surface. There we are. So I'll group these. This input is our mask. I'll make an input for the radius of the sphere. Let's have the density. We can plug a combine XYZ here in the translation. That way we can have access to the Z only here. We can output it and call it offset from surface. And let's have the random seed as well. Okay. This thing, let's call bow sprinkles. If I press Ctrl-Shift-D on this node, I can make a duplicate with all the inputs still connected. I'll make a duplicate of the node tree, and I'll call this star sprinkles. We can connect this to the join as well. Inside, let's get rid of the icosphere. I'm going to use a star curve. Let's make it smaller. Something like 0.1 on the outer radius and 0.05 on the inner. We can use another seed so that it's a different distribution from the bows. I'm gonna make it a 5-pointed star. Then what we can do is we can fill this curve with a fill curve node. This will turn it into a mesh face. We can change this to n-gons. Then we can extrude this, or better yet, let's use our solidify mesh node, include the base, and offset until it looks like it could be a sprinkle around here. Okay, then we can subdivision surface so that it's not so sharp. 2 levels. Okay, but now it's way too smooth. We can use the edge crease to restore some of the definition in the shape. Okay, now the geometry is alright, but as you can see, all these stars are horizontal and kind of point up, which is something that should probably not happen. What we want is to align their rotation with the glazing surface. We didn't have to do this before because it didn't matter the orientation of the spheres, but with the stars it's very noticeable when they're not aligned. So to align them, we can use an align Euler to vector node. An Euler in this context is just a type of rotation. So we are aligning the rotation of our stars by some vector. In our case, we want to align the z-axis of the stars with the normal of our surface, which we conveniently have access to from the distribute points node. So plug that in the vector, then plug this into the rotation of the instances. And there we are. They are now aligned with the surface of the glazing. And truly, we don't really need this because we have an output for rotation over here, and you can just plug this straight into the rotation of this, and it will work the same way. I suspect they've added this so that you don't have to use this node, but I wanted to show this to you so that you know how it works. Okay, but now they are perfectly aligned with the surface, and we want to wiggle them a little bit so that it's not so perfect. So after all this, add a rotate instances node. Then in the rotation, we can plug a random value. This will be a random vector. Now we need to decide on some maximum rotation. I think around 0.4 gives us enough of a wiggle without deviating too far. But we're gonna do this like this, from negative 0.2 to positive 0.2. And there it is. We have some wiggling. Then I will repurpose the radius input to control the size of the stars. So let's use a scale instances node. Then plug the radius in the scale. Now we have a control for the size. Let's rename the input to size. Okay, the final sprinkles are these little sticks. These may look the simplest, but are actually the most involved. I'm gonna disable the other two so that we can focus on these. Here's another shortcut. Control Alt, then right click and drag. Then if I drag over the connections, I can disable them. Okay, let's create another setup. Distribute points on faces. Set it to Poisson disk. Plug the glazing mesh and the mask into the density factor. Then instance on points and join it with the rest of the geometry. Okay, let's group this. Now the base for our sticks is going to be a curved line. I want this to be a horizontal line, let's say on X, So it's going to start from -1 and it's going to end at +1. We can align the rotation like before, so it looks like this now. Then let's give them thickness with a curve to mesh node. Give it a curved circle as a profile. Lower the radius way down to about 0.02 or something that looks good to you. Then drop the resolution to 4. We want these to look like a square base. You'll see later why. And we can fill the gaps on the curve to mesh. Okay, I'll move these to create some space here. Our next job is to randomize the rotation. So rotate instances, and like before, we plug a random value into the rotation. I'll reset these values. I want a full rotation on the Z, so I'll input from -pi to +pi. Pi is half a rotation, 180 degrees. And you can literally type pi, pi, and it will input its value, 3.1415 and so on. Okay, from negative to positive. That way we get one full rotation. Then, like before, to the other two components of the rotation, we can input some small value to give it a little bit of wiggle. Let's try 0.3 and -0.3. Nice. We get total chaos. I can frame this rotation. Okay, the next thing is to make some difference in the length of the sticks. Let's scale instances. If I scale them on X, it will change the length. So let's plug a combined XYZ into this socket, set them all to 1, and now we can change the X with a random value node. But right now we have an even distribution between these values from 0 to 1, whereas, when they're in the packet, they're gonna be breaking up and the longer ones are more likely to break. So we'll end up with a lot more shorter ones than long ones. Well, we can adjust the distribution here, and this is total overkill, but let's do it anyway. We can use a float curve after the random value. This will be our distribution. For the minimum, let's not have 0 length sticks. Let's bump this to about 0.25. These will be the shortest ones. Then we can drag the curve down a little bit like this, so that we have a lot more short ones and less long ones. Okay, we can multiply this to make a control for the length. So let's make an input for that. Length. Now we need to bend them. We don't want them straight like this. We want to give them a slight bend. Let's see how we can do this. Right now we have a curve like this. It has 2 points at the ends. To be able to bend it, we need some more points in the middle, so that, the curve has more segments. Then, to achieve a bent curve like this, we can rotate each successive point by a greater and greater amount. And if we do this correctly, we will end up with a curve like this. Okay, first, let's create more points for our curve with a resample curve node. We can set the resampling method to length. That way, this will divide our curves into equal segments of approximately this length. Okay, now you can see the short ones are more compressed. That's because this geometry here contains instances and the short ones are scaled down. What we can do, and we're going to need to do this anyways, we can create real curves from these instances. We can do that with a realized instances node. You can see now they all have segments of equal length. Now, to rotate the points of the curves, we're gonna use a set position. Then plug the position field into the position. And now what we can use is a vector rotate node to rotate the position. Not a rotate vector, a vector rotate, okay? With this, we can specify the center for rotation, the axis, and the angle. The axis for each curve is going to be the normal of the surface at the position of each instance. So go back to the points and grab the normal and plug it into the axis. The center is going to be the position of each instance. We don't have a position here, so right after the points, let's capture attribute. It's going to be a vector, and what we want is the position. Okay, and now we use this as the center for the rotation. But right now, the angle will just rotate them. Remember, we need a progressively bigger angle along the length of the curve. For that, we can use a node called the spline parameter. And we need the factor output. Now watch as I plug this into the angle. Boom, we have bent sprinkles. To explain what's happening, this factor is a value along the length of the curve, or more precisely along each spline. There is 0 at one end and 1 at the other end. That way the start point is not rotated, the end point is going to be rotated the most, with 1 radian. And in between, it will be a gradient. The midpoint is going to be rotated with 0.5 radians, and so on. Then we can multiply this factor to control the amount of bending. But it looks a bit off. That's because we're bending the curves like this, whereas we want them to be bent from the center like this, so that it's symmetrical. For that, we need the 0 point to be in the center, so that we have a gradient like this. -1, 0, +1. That way, this end will bend like this, and the other end will bend the opposite way. We can do that with a mix node. The factor goes into the factor, and then we can set the range from -1 to 1. That way 0 will be in the center. Okay, let's check it now. Yep, much better. Kinda looks like worms. Now we will randomize this by plugging a random value into the multiply. But now it looks awful. That's because, remember, we need to evaluate the ID, evaluate on domain, set the domain to spline, so that we have a random value for each spline. Otherwise, it's for each point and it's not gonna work. And there we are. We have randomly bent sprinkles. We can just set the random range from -0.5 to 0.5. That way we have bending in both directions. Okay. These nodes are going to be for bend. Now I want to offset them from the surface a little bit. We can come back to the curved line and lift both ends on Z, just a little. 0.01 should be fine. There it is. Now we should smooth these. Let's use a subdivision surface right at the end. And now they start to look like sprinkles. Here you can see why we used a square profile for the curve to mesh. When we subdivide, we will get a really nice squat topology that we won't get if we used a different resolution. And also we get a nice rounding of the corners without it looking weird and artificial. The quad topology will help with the smooth shading. However, you can probably see something is very weird at the ends. This is caused by the curve to mesh. When we fill the cups, it creates sharp edges at the ends. I assume this is because if you want to create like a cylinder, it will have this nice sharp edge. Otherwise, the smooth shading will mess this up and it's not gonna look very good. But we don't want this in our case. So if I preview this, we can take a look at the spreadsheet. If we look under edge, you'll notice we have this sharp edge attribute. It is created by the fill caps. And so is a sharp face on the faces domain. And if we scroll down, we can see some of these are sharp and some of these are not. These are probably the edge faces. In any case, we don't want these attributes, so we can actually remove them. After the geometry, we can use a remove named attribute node. From here, we can pick the sharp edge and also another one for the sharp face. And there it is. We can up one level on the subdivision surface and we have a really nice smooth sprinkles. And this is it. The only controls we may want is for the thickness of the sprinkles from this radius. Let's make it from 0.01 to 0.05, let's say. Thickness. We can also output the density and the seed for the points. Alright. Let's turn the other ones back on again and see what we've got. We can adjust density. Looking good. Okay, our final job is to create these icing lines. If you ask me, they're the ones that really make this donut interesting. And they're the most fun to make. Let's see how we can do them. So we're gonna create them the way you're gonna create them in real life. You probably put some icing in a squeeze bottle, and you're probably going to zigzag the bottle left and right, and the icing will fall wherever it finds on the surface. Alright, what we're gonna do, we're going to create a curved line like this, and then we will project this line downwards until it meets the donut. Let's first create the line. As I said, it's going to be a curved line. Let's join it with the rest of the geometry. I want this line to be horizontal and to span the width of the donut. So it's going to be from, let's see, -2 on x to +2. Okay, then we can move it on Z until it's above the donut. 1 meter is fine. Now we need to make it zigzag. For that, we're going to need a lot more points than just 2. So let's resample curve and make a lot, like a lot, 10,000 for a start. Now let's set position. And we can offset our curve on Y. So let's combine X, Y, Z. And in the Y, we can plug the factor from this spline parameter. Remember, this is 0 here, and in the other end, it's 1. And you can see it's shifted 1 in positive Y. But to make it zigzag, we can use a very cool math function called the ping pong. As I decrease the scale, you can see more and more, I guess, ping pong bounces. But it's also squashing the curve down the more bounces we have. So we need to proportionally scale this curve up with a multiply node. To do this, let's bring a value for the ping pong scale. Then, to maintain a steady scale, we can divide some number by this one. Then this ratio will be our multiplier. Now look, as I change this value, this divide will maintain a steady height for our zigzag, and we can set the height from this value. But it's only on the positive side. So, I'll tell you what, let's set this to 1. So it's a scale of 1. Then we can subtract from it 0.5. This will drop it halfway down. And then we can use another multiply to act as the scale. There we are. So now this will act as a density for our icing lines. Instead of the value, let's use a mix node. Let's see, from 0.25 to about 0.02. You can modify this as you wish. This we will create a control out of icing density. Okay, now we'll project this line downwards onto our donut. For that, we can use a Raycast node. This looks scary, but it's a very versatile and very powerful node. What it does is, as the name suggests, casts rays from each point in a certain direction. This ray direction. And it's gonna give us some information if these rays hit a given target geometry. So our target geometry is the entire donut mesh. Or actually, we can add the donut and the icing later on and just have the glazing with the sprinkles as a separate mesh. This will be our target geometry. We need to specify a source position for the rays. This will be the position of our curve here. We can just plug the position field like this. The ray direction is -1 in Z. That means down. That's what we want. Right, so we have our information. Now let's set position on the curve. The hit position is where the rays hit our donut. We can use this as the new position of the curve. Okay, we got something, but all the other points have bunched up in the center. So over here we have a isHit selection. This selects which points actually hit the donut and which don't. So let's use this in this selection of the set position. And there it is. This curve has been successfully projected onto the surface of the glazing. Now let's give it some thickness so that it's more visible. Curve to mesh and give it a circular profile. Now you can clearly see how it's laid on top. Okay, now these leftovers we're gonna delete because we don't need them. Let's delete geometry. We can use this selection. However, we need to invert it so that it selects the points that do not hit. Remember, we can invert a boolean by using a not from a boolean math node. Alright, now plug this in the selection of the delete. Okay, now, but the way curves work, when we deleted those points, it kind of reconnects the leftover segments to create a single spline. We obviously don't want that, so what we can do is we can convert this curve into a mesh by using a curved mesh. Now you can see it doesn't connect them. Then, after the delete, we can convert back to a curve with a mesh to curve. And there we are. We have our icing lines. Now, you'll notice it goes over some of the sprinkles, but it goes straight through the balls. And that's because these balls are instances. You can see we have a message on the Raycast. Instances in input geometry are ignored. So we can realize that geometry before the Raycast, and there you go. Now it goes over the balls and over the stars as well. Now, if we look at this geometry, it is a bit harsh. The curves make very sudden jumps. What we can do is we can resample this curve again, use the length mode again, okay? Then we can smooth this up a bit with our smooth geometry group. Now, what I think we should do is deal with the thickness of the icing. I want it to be thin at the ends and sort of have variation in its thickness. Let me preview just the icing. We can control the thickness by using a set curve radius node on the curves here. This will change the thickness of the line. Now in here we can plug a gradient such that it has zero thickness at both ends, and in the middle it should be 1. We can plug the factor from a spline parameter. See, this is 0 to 1. But we wanted 0 to 1 to 0. So let's remap this with a float curve. Instead of the 0 to 1, I can change the curve like this. 0 to 1 in the middle and back to 0. Okay, but now it's a bit too wispy at the ends. So we can use a power function to push the values a bit. 0.5 should be okay. There. Now what we can do is multiply this, and we can multiply it with a noise texture. Okay, this will create some variation in the thickness. Let's remove the detail And we can use a 2D texture because it's just along a line. Now you can just play around with the scale of the noise to adjust the bumps. We can also multiply this again, and this can serve as a thickness control. So we can actually create an input for this, icing thickness. Also, we can get the icing bump scale. Okay, last thing, these lines, let's wave them a little bit so that they are not so straight. We can do this over here before the raycast and the set position. We can add another set position. This time we want to offset the line on X. So let's combine XYZ, and in the X we can plug a noise texture. Alright, not normalized, no detail, and lower the scale a little bit. This is a bit too strong, so let's multiply this noise down. Then we can make a control for the scale, and we can set some maximum scale. Something like this, like 6. Alright, now this will be icing lines. And we can set this noise texture to 4D so that we can have variation with this W. There it is. I'll just tidy up the node tree now. And you know what? I'd say we're finished with the geometry. We've used quite a lot of new nodes and new techniques. You can go around and create any other control for whatever part of the geometry you want. Or what you can try to do is create some other type of sprinkle. That should be a very good exercise. Here I photographed some examples of different sprinkles. In the next video, we'll make this looking good by creating all the materials. So, see you there.